Welcome everyone to this final dialogue for the annual cycle for TRAJECTS. This is something that we're calling rare but relevant energy sources in the global discussion. This is part of the cycle of dialogues beyond the wind and the sun, dialogues on clean energy in the just energy transition that we've been holding monthly, and that today, in the day for action against the day for action against climate change, we have three special guests from three continents: Germany, Africa, and Latin America. To me, Nataly Díaz Cruz, the academic coordinator for the LATAM hub of TRAJECTS, it's a pleasure to be able to moderate this space today, and it's a pleasure to share this time with all of you. Hopefully, we're going to have very interesting dialogue today. The methodology for today is to first have participants to tell us about, well, these are researchers, experts, who will tell us about three different sources of energy that we call rare energy because they are somewhat less popular than wind and solar. And that's why they're considered to be rare, but very relevant because obviously they too have great potential. And some of them have already achieved major impacts in the just energy transition, and especially with regard to clean energy, because all of them are renewable energy sources. So first we'll have a presentation by Dr. Andrés Osorio that I will introduce in a moment. He will tell us about energy associated with the ocean and different sources of energy that is wave driven. We will then, I think the order is different on the slide, but then we will listen to Imane Boukhatem, who is a PhD candidate in Flensburg University. She works in green hydrogen and will also tell us about hydrogen. And then at the end, we will have a presentation by Dr. Danielle Fendji from Cameroon, who will tell us about geothermal energy. And Pedro Pablo Salazar will complement that presentation. He's an expert in environmental studies and is going to receive a master's degree in geothermal energy in Colombia. So at the end, we will see how geothermal energy can have things in common between Latin America and Africa. So after each presentation, we will have 5 minutes to talk. And then after going through the four panelists, I will ask them a few questions so we can keep talking about how these rare energies can or cannot be shared in a diverse energy matrix and how they might contribute to the just energy transition. So, welcome. To our participants, you can share your presentations. We had said before our dialogue that we would be presenting in a different order. So we're starting with Imane from Flensburg University, and then we'll continue with Andrés Osorio, and then Dr. Danielle Fendji, and then Pedro Salazar. So I will now introduce Imane. Imane Boukhatem, I'm sorry if I'm pronouncing your name wrong. I'm not sure how to pronounce it in English. Is a researcher, a doctorate researcher from Flensburg University, specifically from the Center for Sustainable Energy Systems, or ZTENS, and is a research member of the Fossil Exit Group working on the exit of fossil fuels from the world energy matrix. There, she is part of a just energy transition team, and her research explores how the global south can navigate or can engage in the just energy transition to overcome the various difficulties that entails, and is specialized in natural gas and green hydrogen. She has a master's in energy policy from Pan-African University, from the Pan-African University for Sciences and Energy, and she has had publications in the Sustainability Nexus Forum and the Renewable and Sustainable Energy Transition magazine. She has also engaged in the just energy transition in the region and in Arabia. Welcome, Imane, and thank you for being here. And you have the floor.
Thank you very much for the invitation. And I will share my presentation to start straightforward on the topic of green hydrogen. So excuse me about my voice. I don't know if you can hear me well. Because I have a little cold. So in today's presentation, I will share about insights about green hydrogen and focus on the justice perspective. So we'll start with an introduction. Start from the beginning. I will share a presentation today about I will share some insights on green hydrogen from the justice perspective. The outline of the presentation, there will be a small introduction, hydrogen production and use, green hydrogen risks, and hydrogen from justice perspective, then a conclusion. So hydrogen is not a new energy carrier. So it's not an energy resource by itself, but it is an energy carrier. So it carries energy from other resources, and these resources can vary from fossil resources like coal and natural gas to renewable energy resources. So the production and use. So we have different colors of hydrogen that vary from the black to the green, and the green gas green hydrogen gas footprint from high to minimal. So we have the black, the brown from coal gasification, the gray from natural gas, the turquoise and blue also from the gas with carbon capture and storage, and from electrolysis, we have green hydrogen is from electrolysis with electricity produced from wind, solar, and hydro, the renewable energy resources, and it has a greenhouse gases, like the footprint is minimal. Hydrogen could be so I'll start so we have the different colors. It varies from blue to green, from black to green, and it could be produced from from fossil fuel resources to the renewable energy resources like the green hydrogen. And only green hydrogen from renewable electricity, from electricity produced from the renewable energy like wind and solar, has a minimal greenhouse gases footprint. So we have the production of of like green hydrogen. So we have the production, the transformation, the transport, and the end use. For the production, like we have the production of renewable electricity from renewable energy, electrolysis. It could be used directly, the hydrogen, or it could be transformed into a green ammonia or synthetic fuels. Then there is the transport or the storage until the end use that could vary from industry, transport, heating, and power generation. So, however, theoretically, the use of hydrogen could be in many applications, but like the combustion of hydrogen in the gas-fired power plants for electricity production, as a fuel for transport, in industrial processes, including steel production or for heating. But it is important to say it is like some or like many of these applications are not cost efficient. So here we have like to explain like the efficiency. We have the direct use of electricity that is 100% efficient. Like hydrogen is 67%, ammonia is 54%. So always the direct use of electricity is like the most efficient way. So these are some many cases where we can use hydrogen, including the power system and the fertilizers. However, there is a scale of efficiency, and at the A scale are the uses where hydrogen cannot be replaced. So we have the fertilizers and hydrogen, for example, the fertilizing. So like all the yellow applications could be replaced by electricity and batteries, the green by biomass or biogas, and only the red are the applications where hydrogen cannot be replaced. So the more centralized the more centralized the use of hydrogen, the more efficient it is. So like using hydrogen for heating, for residential heating, which is a distributed application, is very low, is very low in efficiency, or like somehow very inefficient. So from 2021 to 2023, there was a political hype around green hydrogen, and many politicians have said like green hydrogen is the champagne of the green transition. Renewable hydrogen can be the game changer in the global effort to decarbonize our economies, and hydrogen can tackle the critical energy transition. So it was like there was a hype, and it was described like the missing link of the energy transition, or like the magic solution for the energy transition. However, it is important to explain that green hydrogen comes to decarbonize the latest percentages of the energy mix. So when the whole mix is decarbonized and the very few last percentages remain, here is like in these last percentages, we need green hydrogen. But when countries still struggle in decarbonizing their energy mix, like hydrogen is not that needed. So it comes like an efficiency and electrifications and the introduction of renewables of the energy mix are more prioritized, like in the case of these countries. And it comes to decarbonize the hard-to-abate sectors where electrification is not possible. We have explained some of these industries, like the fertilizers industries and the production of steel. The global north economies need green hydrogen to achieve carbon neutrality. So as the global north have objectives of carbon neutrality by 2050 as an average, or 2045, they need green hydrogen to reach this carbon neutrality. And most of these countries, the global north countries, do not have sufficient renewable energy resources for domestic green hydrogen production. So they need to import it from global south countries. And green hydrogen import policies and agreements are already in place. There is a form of hydrogen diplomacy where we have seen countries, the global north countries discussing import from the global south countries, and we have seen many or most of the countries publishing their national hydrogen strategies. So behind the hype, green hydrogen risks. So what are the risks behind the production of green hydrogen? The first big risk is water scarcity. So hydrogen, water electrolysis for the production of hydrogen needs pure water, pure drinkable water. And this could create a conflict of views between the hydrogen industry and other domestic uses like agriculture or how the household need of clean water. And most of the global south countries suffer from water scarcity. The second point is desalination. So desalination could be a solution, but desalination at a large scale will enhance the price of hydrogen, and it threatens the aquamarine life systems. The risk of leakage. So hydrogen is very light. And there is a risk of leakage. It could easily escape the containment during production and storage. And the leakage rate varies from 0.2% to 20%, depending on in the production, transport, and end use factors. And 70 to 80% of hydrogen is absorbed by the soil. So hydrogen is not a greenhouse gas. So it doesn't have a direct risk for the climate, but it can increase the potency or the life of the other greenhouse gases in the atmosphere. And another problem is that hydrogen is highly explosive. And we have seen like these safety, we have seen, so it raises the problem or safety concerns. So we have seen the Beirut explosion, and that was because ammonia was not stored properly, and the explosion have resulted in more than 200 victims. The other indirect risk is the climate policy risks. So as I have said before, that green hydrogen is needed to be produced in the global south and imported to the global north. and it is very capital intensive. So like global South governments decide to diverge their investments from, for example, electrification or expanding the renewables to hydrogen, there is a big risk for the domestic energy transition, and all the money will go from the other climate mitigation policies to the green hydrogen policies, and will result in a scenario where our countries consume gray energy domestically and export green hydrogen. So as in this final slide, I would say that now the production and the export of green hydrogen is inescapable. It's already the hydrogen transition is already happening, and there is a need for awareness to make it a win-win partnerships between the global South and the global North. So it's important to have a social license to operate from the companies that will install the big wind and solar farms. And it's important to see it as an opportunity for green industrialization in these in the global South countries. So instead of exporting raw hydrogen, the export of its derivatives like green steel or ammonia will be more benefiting to the domestic context. So, and here are some benefits if the green hydrogen economy is being approached in a sustainable way. It could reduce the air pollution. It could contribute to improve the water supply for in the global South. It could enable the green industrialization of the global South countries. It will create direct and indirect jobs in the value chain and contribute to improve the access of energy, improve the access to clean energy in these countries. So having a good win-to-win agreements and having local content requirements for these projects is very important. So that was my conclusion, and here are some references, and thanks for your attention.
Thank you, Imane. Well, so far we don't have questions for you, specifically for you in the chat, but before we move on to our next speaker, I would like to ask you something. So you mentioned that even if there are some risks in green hydrogen specifically, at the end, you show how it is also an energy that may bring plenty of opportunities, especially for the business center or sector, for the industry or business sector. And you also mentioned that the green hydrogen should be produced in the global South to be exported into the global North. So specifically considering these two upsides and downsides and all the research you have conducted, do you consider the global South, specifically countries that are just reviewing their policies in order to start to implement hydrogen, as in the case of Colombia, hydrogen-related policies, should these countries prioritize green hydrogen-based research as opposed to research on other types of energies? Or do you believe this boosting of green hydrogen-based research should be considered just after having considered other energy alternatives or having developed other alternatives?
So if I understand well, it's about the education programs, like as a form of just transition. Because I was listening to the interpretation. So can you shortly repeat the question? Is it like how the Global South countries will have to
I came to this channel. So the idea is, my question was, you think that for the Global South countries, it will be that is still are thinking in invest in this kind of energy. It will be important to like give the advantage of the hydrogen over other kind of sources, or it will be better to develop other sources or other strategies, and after have like this stable sources of energy, start improving or the research in hydrogen. So because you mentioned that the South produces the hydrogen for exporting to the North, the global North, but how can this contribute to the global South in itself?
Thank you very much for your question. I think like in order to expand or to have a green hydrogen economy or to export it, it's important to have the green skills in both solar, wind, geothermal, like all the renewable energy sources. So I think like education of preparing the green skills for a green hydrogen transition is very important. And studies also show that green hydrogen, except for the construction phase, will need highly qualified engineers to run these plants. So once partnerships in place and offtakes are secured by the global North countries, like when they sign contracts to import certain amounts of green hydrogen, it's important to have the needed skills. This is where the technology transfer and the North-South cooperation is important. Thank you.
Thank you, Imane. There's another question. And the question is, what is the approach in terms of research?
Yeah.
In order, just a second. Okay, I think it's better for you to read the question in English. It's in the chat box.
Yeah, so the question is, what is the research focus on hydrogen storage materials in the green hydrogen perspective? I think it's out of the scope of my research. So because I research hydrogen from a political economy perspective and not like from an engineering perspective. But what I know is like ammonia is used to transport hydrogen like as a form, and I unfortunately cannot answer this question.
Thank you, Imane.
You're welcome.
Those questions that are more technical or engineering based perhaps may be answered in a different space. Thank you very much. So now we will hand it over to Mr. Andrés Osorio. He is a civil engineer with a master's and doctor's and a PhD in marine sciences. He is a professor in the Medellin seat of the Universidad Nacional. He directs the specialization in oceanography and coastal engineering, and he's also the executive director of the Excellence Center of Marine Studies, CEMarin, one of our partners in TRAJECTS in Latin America. He is very knowledgeable of the management of ocean and coastal areas. He has been conducting retroanalysis and forecasts and waves, high tides, and the design of solutions for coastal engineering and ocean sciences. He has been involved in many international projects related to science and technology, ocean science and technology. And it is a pleasure to have Professor Andrés Osorio in this dialogue for him to share with us about this second rare but relevant source of energy. Thank you very much, Nataly. Thank you very much for this invite. And I want to greet my peers in the panel, Pedro, Danielle, Imane. And on my side, I'm very happy to be able to share this rare energies. I've always been a promoter of marine-related matters, and this is the area, or one of the areas I have performed. And so let me share my screen to share some slides with you for my presentation. I think I'm sharing. Presentation mode. Yes, there you go. It's working now. All right, perfect. So we will talk about the challenges of engineering for marine and oceanic energy. So let me introduce myself. Nataly has introduced me. I just wanted to add that I'm a part of the CEMarin Center. I am a researcher and professor in the Universidad Nacional, National University, and I was appointed executive director of the center, where I have been part of the directorate, and this is a center that comprehends 8 universities in Colombia and 2 universities in Germany. Here are the universities. We have the Andes University, the Valle University, Antioquia University, and the 2 universities in Germany are the University of El Norte, Cartagena, Magdalena, Tadeo Lozano, ZMT, and Kiel University, both in Germany. I want to thank CEMarin and TRAJECTS because, like Nataly mentioned, we are partners, and we have boosted this alliance between fair transitions and marine-related topics. So this is a context I will try to address in this few minutes. We will talk about regulations, motivations, the ID plus I, economy plus economy, potential and applications, communities, the potential of connecting and communities. And the first idea I want to bring forward is that in the case of Colombia, the first thing that people don't know, people fail to be aware of is that what we see in this map, thanks to Malpelo and San Andrés and Providencia, we have a significant marine area. However, from the optics of the marine development, what we need to do is to get acquainted with our marine resources and put together sustainability plans and for marine purposes specifically to put our bets in sustainable development in the territory. Therefore, the country has conducted efforts to try to what we call exploration blocks in hydrocarbons and then gas exploration, and also in wind marine energy. So when we talk about wind energy or ocean wind energy, we think in a different way because we're not talking anymore about the land, but other different challenges, platforms that will be in constant movement dynamics. So there is this is the the timeline before the CEMarin and National University's research. So that started over 20 years ago. We started some efforts, and we used mathematical models to reproduce the ocean variables, the wind, of course, but then other variables such as tides or waves. So there are some projects like the ANH, National Hydrocarbon Association, as you can see to the right-hand side, but also some exploration projects to collect data, ocean-related and environmental data, but also projects having to do with policies and offshore regulations for the Ministry of the Environment. A very nice project we have here when we see this robot, it's called submarine robotics. We did hand in hand with the Pontificia Bolivariana University and Ecopetrol to develop this capacities. The Pioneer project with EPM, Public Companies of Medellin, marked the first roadmap of ocean or marine energy in Colombia, and so on and so forth. There have been many projects, and I just wanted to mention some of the ideas and some of the challenges that this type of research entails. And thanks to the German cooperation and the cooperation with National Geographic, we have brought some oceanographic cruises that have allowed us to get to know the marine biology and characteristics before we talk about energy. So in the case of CEMarin, we also operate with the Colombian Commission of the Ocean. For example, the National Plan of Expeditions for 2023, where we explored in San Andrés as well. There's a picture of San Andrés here, the keys here. So that's the first thing to get acquainted with, to explore and acquire some knowledge. So this initial motivation, considering this oceanic ocean variables and the potentials thereof, also entails certain challenges, and we managed to think about public policy and regulatory frameworks that help build in these marine-related topics. So in 2014, renewable energies in this Renewable Energy Act, or unconventional energy sources, the sea energy came up. This concept emerged, like Nataly mentioned. When people think about the ocean energy, they think about certain a type of energy that we have, the tide-related energy, but there are some more ocean-related energies that we will talk about. But the purpose is to take advantage of the oceans, understanding the waves, the tides, the different thermal differentials. So there are different potentials. And also this has to do with the fact that Colombia also launched the hydrogen route, and hydrogen may also be drawn from the ocean energy, like the case of the Colombian Pacific with colleagues from the Valle University. We have been working on some ideas to generate green hydrogen from this ocean energy and export it towards, and we will have a new potential for the industry. So marine energy and developing hydrogen and developing the Pacific in a different way, for example. So this is an idea that must be assessed, of course, but it is part of the roadmap. We also have a roadmap on the offshore wind energy. Recently, there was an offer by a Danish company for the first marine wind plant, wind energy plant. So in 2022, talking about transitions, the government issued an act about energy transition policies. And considering all of this framework, we determined that we need to create knowledge around this. So where are we now? In the case of Colombia, we have been we have been conducting research for 15 or 20 years, and you can tell this in around marine ocean energy. We have scientific publications, over 40 papers in the country. It seems a little number, but it's a lot. I think it's a lot. The fact that we have researchers and we are creating articles and papers and publications around this topic, and we compare ourselves to the rest of Latin America. I don't have this in my slide, but this is part of a paper we published. Colombia is ranking 3rd in terms of countries that produce the most research. The first one is Brazil, of course, due to its size. Then comes Chile, and then Colombia. So Colombia has a great potential. You can see in the graph to the right-hand side, we see the types of energy or the topics of research conducted. The first one has to do with wind energy, so it's where we have the offshore wind energy. The second icon refers to the salinity gradients, and I will explain why. It is one of the greatest potential Colombia has, and we'll tell you about the difference between freshwater and seawater. And in the case of Colombia, the Caribbean Sea has a very high salt content, and we have great or big rivers such as Magdalena, and these gradients may imply potential. So much research has been conducted because we are considered a world power in terms of this gradient, salinity gradient energy or osmotic energy. We have the wave energy with a lot of research as well. We also have thermal energy in the ocean, the difference between temperatures or the difference in temperatures in the ocean. And the last one is the tidal energy that has the least research. So these are affected by the sun and the moon and meteorological factors, but the tide changes within 12 hours or 24 hours in contrast to waves that are there the whole time. So this type of energy is called as determined by the ocean. Why is this important? At the end of the day, we are looking for fair transitions or energies and renewable energies, and we want this to generate a dynamic of a different economy. And one of the economies that emerges as a concept is the ocean energy, in this case, the blue energy. And we want to take advantage of marine resources. So this is why, since two years ago, we had a course based on mangroves, because mangroves capture carbon, generate the biodiversity, tourism, and they are the greatest source of carbon capturing. So there's a connection between blue economy and nature-based solutions and energy potentials that we could also explore. So at the end, we have room for this. And we noticed that the industry, the ships, the vessels, wind energy, fishing, but we haven't thought a lot about the fact that the blue economy may foster or create an increase in the baseline of biodiversity. So when in this image to the right, we expect that the blue economy and nature-based solutions not only will develop technology and taking advantage of resources, but it may also generate a net production of biodiversity, meaning increasing the biodiversity. We see new coral reefs. We have seaweeds and a huge potential in marine wind energy connected with underground lines, creating places for biodiversity. And this is a great potential. So this is why it is so important, in the connection between motivations and the research conducted in Colombia, the regulatory framework, and the connection with the economy. And very quickly, let's take a look at the potential we have in Colombia in terms of wave energy and tidal energy. In the Colombian Pacific, we have around 5, 6, 7 kilowatts per linear meter. It's not a lot as compared to the northern seas in Europe and so on. But it's important to see that the Colombian Pacific is in an area that is not interconnected, and it has a stable energy year long. So that is very interesting. In the Caribbean, the waves may have more than 7, 6, and it could be 10 kilowatts per meter, but by seasons. So in the area between Barranquilla, Santa Marta, for example, there are some specific places with a super high tidal energy potential for a calm sea like the Caribbean. And the potential in terms of tidal energy, we're talking about 2,600 watts per linear meter. So we have the Pacific with a great potential as well. And we have some technological developments. This is a Colombian researcher, Jose Montoya, we have been working with, and he developed a wave energy device, and we are conducting some tests in the Medellin National University with a wave channel. So it's very interesting to develop technologies in addition to this potential. So talking about these two resources, we are talking about the temperature and salinity gradient. So I will start with the temperature gradient. So areas such as San Andres they have 28 degrees. That's the temperature of the ocean, and in depths we can find 5 degrees in temperature. And this gradient of 20 something delta is enough, or gradient is enough to generate thermal ocean energy. So this works as the Rankine cycle, which is I evaporate a fluid with the temperature and it is condensed in the cold. So this generates a gas in circulation that activates a turbine. So this is how thermal energy works in the ocean. San Andres has a great potential. Santa Marta has a great potential. And I would like to emphasize the concept of salinity, as I mentioned. I want you to think that in the case of the Magdalena River, it is a river with 7,000 cubic meters by second. That's the flow. And some times of the year, the Magdalena River has a potential. The average potential of Magdalena River after environmental limits is between 600 and 800 megawatts of installed capacity. This is the third part, 800 megawatts, 800. So that's the average, but it could reach up to 800, and it is the third part of the potential Ituango has, which is the second biggest hydro electrical power plant. So it could generate like a third part of this energy plant, but we need to develop this technology so it could supply for the Caribbean, for all the area, but we need to research. So we have conducted some research and a laboratory here in Medellin, and hand in hand with the Universidad del Norte University and the National University and Competencias, we conducted the first field pilot in an area called the Puerto Mocho in Magdalena. We have placed a container with the first salinity gradient energy prototype, not only in Colombia, it's not only the first one in Colombia, but in Latin America, because we have this huge potential. We can be a great exporter of science, knowledge, and technology of this type of technology. In the case of San Andres, thermal ocean energy connects this energy with the needs an island has. An island such as San Andres uses diesel energy. Meaning it needs local energy. So energy, this could be a solution, but we need this to represent a different development model. So we talked about a different concept like ocean plants and desalination of water, agriculture, and nutrients, and so on. So it's not only energy, it's water, it's nutrition, it's sustainable development. So this is why we have conducted this project and research initiative. So in summary, Colombia has great potential in salinity gradient energy and thermal energy, tidal energy, wave energy, both in the Caribbean and the Pacific. And at the end of the day, we could be talking about the possibility in all those marine territories of having access to rare energy sources different to the current installed capacity and energy that is needed that we need to provide. Also important to mention, we accompany these projects with monitoring of resources, temperature, but we are accompanied by communities. We have a project in San Andrés of monitoring coral reefs, because if we develop, this is how it works. And on the right-hand side, we have a place in Punta Soldado and Tribuga in Chocó with communities we have been working with on the monitoring of ecosystems. I think, well, these are some of the conclusions. There's a huge potential for Colombia and Latin America, their capabilities. We need to develop more potential in terms of knowledge in networks, and but this type of networks and dialogues are very encouraging for those purposes. And this, in the case of Colombia, we want to develop a testing center in Barranquilla in salinity gradient energy, not only in Barranquilla, but also we also have potential for tidal energy and offshore wind energy as well, and of energy. So thank you very much. This is my contact info, and I hope we're still okay in terms of time. Thank you, Andres. That's okay. Thank you very much. Like you mentioned, after listening to you, we can conclude that ocean energies are more relevant than rare because, like you mentioned, there's a great effort conducted around these energies in terms of research, but there have been many myths around to what extent we can use ocean energies, and we continue to favor different types of technological innovations related to wind and solar energy. Therefore, it is very important to continue to deepen the conversations on this topic and research like the one conducted by CEMarin. We don't have any more questions in the chat, but I do have one question for you, and it has to do with the today's celebration, which is the action against climate change.
I was drawn to the different kinds of energy you've presented, and I did want to ask you then, how could climate change affect the dynamics of marine energy, especially in the thermal gradient? So how would the modeling be affected as well with regard to what that kind of energy could provide? Thank you for the question, Nataly. Very complex, although very pertinent. I wouldn't have a very concrete answer, but I could give you two ideas just to maybe think about. The first is that whenever we harness energy, what we're doing, as we all know, energy isn't created or destroyed, it is simply transformed. So what we do is take the energy from a thermal source or from the tides or from whatever, and basically take the energy from there and let's say harness that efficiency, thermal efficiency. We're taking heat and we're also taking cold from the bottom of the sea and transforming it into energy. So I think at a local scale, it may have a positive impact in a sense that we're removing heat from the surface, but it's very localized. So many ocean thermal devices would have to be deployed worldwide to actually remove heat from the ocean, which is one of the issues we have. But removing heat from the ocean will not necessarily affect the heat in the atmosphere and the polar ice and climate change as a whole. So the hypothesis, so that's the first idea. The first idea is that there may be a local impact, but the hypothesis that we all have is that no matter what, using renewable energy will reduce emissions, CO2 emissions, and the greenhouse effect. I would also note about what I said about the blue economy. We can use marine energy, but we also have to start to decarbonize our entire economy. So, for example, I might take carbon from other technologies or other activities, and use the marine ecosystem, if I have a marine system in place, to store carbon, as we do with mangroves. So I might have a marine park with generation and capture, and somewhat ease the effect of carbon in the atmosphere, which is the most important thing. Just giving you some ideas. Great. Hopefully later on we can keep talking more in depth about this. Thank you very much, Andrés. Thanks to all of you. We will now continue with our third rare but relevant energy presenter by Dr. Danielle Fendji. She was trained in applied physics and electronic and electric engineering from the University in Cameroon, and she is currently in the School of Engineering and Technology at Buea University in Cameroon. She's very interested in renewable energies and capturing solar energy, charging batteries and power electronics, and of course, geothermal energy, which is what she will be talking about now. Just to finalize the introduction, I'd like to mention that recently she was a trainer in a course on the energy transition with a gender approach, which is the approach that she has also been implementing in her research. So welcome, and you have the floor.
Thank you, Nataly, for the introduction. Welcome, everyone. So let me share my slide. So today I'll be talking on geothermal energy in Central and West Africa. So I'll be talking about energy access. That is a challenge in those two parts of Africa. A little introduction on the concept of geothermal, the potential in Africa, and how geothermal can help to mitigate climate change, the major term opportunities, barriers and challenges, and policy and some recommendation. Central and West Africa face a lot of challenge in energy access. So as we consider here the figure 1, you can see that Chad, Central African Republic, they have a electrification access rate that is even less than 20%. If you consider also Mali, that is a West African country, also less than 40%. Why? And because Central and West Africa are really dependent on aging power plant, and also because of that, we have many millions of people that are lacking access to electricity. And this is having a consequence on economic activity because some are really limited because of the access of electricity. One reason also for the low rate of electrification is low income that restrict also the affordability of electricity services in West and Central Africa. So what are the main sources, primary sources used for generation of electricity energy there? We have coal, water, solar for solar power plant, wind power plant, and oil. Let's talk about the concept. When we are talking about geothermal, it's made of two words, geo from geology, earth, and thermal that come from heat. So this is a very basic geothermal power plant. Here we have the injection well, production well. So the geothermal is a concept. You are tapping under the head to take the resources. So water, hot water is pumped from the well that have been drilled to the exchanger, the heat exchanger. So steam is released, then the turbine can spin. It can the steam will spin the turbine. Connected to the turbine, we have a generator that will transform the mechanical energy to electrical energy. So electricity then is produced. The water collected is sent back to a condenser that will turn the steam to water and inject again in the injection well. What is the potential, geothermal potential in Africa? So as you can see the different map of Africa. So we are going to display here. We can see that at at 1 kilometer depth already, we have some few countries like Ethiopia and Kenya that we can already observe 150 degrees Celsius. And when we are going deep again, 2 kilometers, there are some few other countries that are adding, Rwanda, Burundi, and we can already reach 200 degrees Celsius. As we are going deeper, the value of the temperature is still increasing. What is the geothermal potential in Central Africa? So from the previous slide where just we consider that is only the east part, let me take it back, mostly the east part of the Africa that was showing already the potential right from 1 kilometer. So what is the case of Central Africa? So the Democratic Republic of Congo is the one having the highest potential in Central Africa. He has also one geothermal plant has been implemented there 1952, then have been decommissioned. So it was just to supply a tin mine. Now there is no implemented power plant, and the government is having an interest of growing interest on the geothermal. In Cameroon, more than 130 thermal springs along the Cameroon volcanic line have been detected, but till now we have no feasibility study or power plant, not yet. So many other countries like Guinea Equatorial, Republic of Congo, they're still in the phase of exploration. There is no power plant that has been already implemented. What is the case now of West Africa? Cape Verde, yes. The current status, there is a feasibility study that is underway, and also pilot projects are planned with an international partner. But concerning the other, Ghana, Nigeria, Ivory Coast, Senegal, there is no generation, and the study are just mainly academic. When we are talking of geothermal energy in Africa, we have the leader, that is Kenya. Kenya is leading with already 939 megawatts of geothermal energy installed. It's followed by Ethiopia. As you can see, there are only the two countries that have already implemented the geothermal energy. So let us talk about the technology, because sometimes you have difficulty of implementing some solution because we are not having all the different technology. For the extraction of geothermal energy, we are going to present to the enhanced geothermal system and the EVO loop. For the enhanced geothermal energy system, we have an artificial well that is drilled, and water is injected with a very high pressure that is going and create some fracture. So the water introduced will be heated, and the water heated will be collected and sent to the surface using production well. The EVA loop is having, we can consider this one as a closed loop that is also using less water. So we are also calling it geothermal everywhere. It requires just deep hot rock to be implemented. And also the advantage of this EVA loop in front of enhanced geothermal system is that it also provide more security, is less risky than enhanced geothermal system. As we are talking of geothermal energy, let us look at the different applications. In Cameroon, agriculture is the cornerstone. So geothermal energy, we have two use. We have direct use, the production of heat, and indirect use for the production of electricity. In the domain of agro-industry system, heat can be used for soil warming, for drying of crop, with harvest, harvest of crops. Sometimes we don't want to have some loss. There are some processes like drying that can be very important to be able to keep our crops well. And also another application is industrial uses, biogas processing, coal drying, cement drying. The next application or use is the production of electricity by using a binary cycle or flash cycle. We can notice that all the different applications are done at different level of temperature. We also want to look now at the difference between geothermal implementation and other resources, other renewable energy sources like solar and wind. The first advantage of geothermal is the availability, 24/7 base load power, whereas solar and wind are intermittent and weather dependent. We have also concerning the land use, geothermal offer low land footprint, carbon emission very low, near zero, and also for the dependence of the location, geothermal is requires geothermal site. We also have very high drilling and plant costs for the case of geothermal, that the upfront cost for wind is moderate and low for solar PV. The environmental impact, so we have some seismic risks and also habitat disruption possibility is possible. So now the last aspect that we want to consider is energy price stability. So with geothermal energy, we are going to offer stable and predictable energy, whereas solar and wind energy are variable, dependent on also on storage. So we just noticed that in West and Central Africa, there was no concrete implementation already of geothermal power plant. So these are the list of some barrier and challenges that we notice. So the high upfront costs due to the exploration and really that are capital intensive, that is already a barrier. Technical expertise, so we have the lack of manpower in the geothermal resource assessment in this region of Africa. We have also weak regulation frame and unclear policy concerning energy. You have limited geological surveys and confirmed data. So we have lack of data concerning the different regions. Also, one important point is the lack of funding for research and development. And the last that we are talking about is the social and environment issue that can bring potential land use conflict. Now, let us look at how geothermal can mitigate climate change in those particular areas. So, geothermal offer low carbon emissions. So, we have more than 99% less than other sources. And geothermal energy is one of the cleanest and continuous energy source that is available in very large quantity, because it provides 24/7 renewable power. And also, geothermal can help to replace fossil fuel that bring a lot of pollution. Also, another advantage is efficient land and resources use. The last point here also should be the support of sustainable development. So with geothermal, we are going to contribute to long-term decarbonization goal, meet the climate Paris Agreement. So what are the opportunities that can offer geothermal? We have technological innovation, direct application that will provide benefit to community, and decentralized energy access. Like small geothermal project can support rural electrification. We also open door to international collaboration so that regional knowledge should be shared and we overcome the barrier, and also lower the risk of the different projects. It can also create a lot of jobs and the growth of economy. At the industrial level, we notice a decarbonization because it will offer stable and low carbon base load power. What are the different policies? To regard to the report of IEA 2024, so for the promotion of geothermal energy, we have to conduct deep geological survey and exploration, also develop policies and regulation framework to support the deployment of geothermal energy, build capacity, local capacity and expertise in geothermal. Also, we have to prioritize direct use, utilization of geothermal energy, that is for heating, encourage international cooperation and knowledge sharing. So we can also say build pilot project and well for deep exploration. So this is the end of my presentation. I also want to say that geothermal is promising versatile renewable energy source with a vast untapped potential for electricity and generation, heating and cooling in West and Central Africa. Thank you so much for listening. I will stop sharing.
Thank you, Danielle, so much for showing us this perspective of Central and West Africa and geothermal energy and how it's being applied. You mentioned in the first few slides, when you explained how geothermal energy works, how important it is to have water to generate electricity. So thinking of Imane's presentation as well, I wanted to ask you, what kind of relationship is there between water scarcity and geothermal generation? That is there a conflict between geothermal energy production and water scarcity?
Thank you so much for your question. It has not yet been implemented here in Cameroon, but in Kenya, geothermal has already been implemented. So we have we said steam thermal plant where the challenge sometimes that uses water, the challenge is the water availability. Mainly when we have to introduce water, so water should be available. I don't know if I've gotten your question very well, and yes, or you need more explanation.
No, I think that was good. If anyone in the room would also like to ask a question right now, please go ahead and write that in the chat. But okay, we will now hear from Pedro Pablo for the Latin American perspective, and then in the meantime, maybe more questions will come up for all of you. So if it's okay with you, I will now give him the floor, and we'll come back to you. Thank you. Ready, Nataly? Yes, let me introduce you first. So thank you, Pedro Pablo. He is currently a master's candidate on environmental development from National University of Colombia at the Environmental Studies Institute. He's an environmental engineer and environmental manager. Recently, he did his master's thesis on geothermal energy, and he'll be telling us about that. So I'll give you the floor now. Great, thank you very much. Nataly, I will first of all share my screen. Great, so very thankful for the introduction by Nataly. Good morning, everyone. I am Pedro Pablo, a master's candidate on environment and development, and I just want to supplement Danielle's very valuable presentation on geothermal by adding the Colombian context. This is a relatively new energy that is still in the process of being developed and implemented. Under the energy transition that may have many branches, especially when it comes to diversifying and increasing the installed capacity of energy generation in Colombia. But like any other resource, it may also be subject to certain environmental impacts, which are important to analyze for prevention purposes. And it's also very important to consider the just energy transitions. So since this is a longer thesis, I won't go into the details of the thesis, but because it would take a long time, but I will focus on several parts that are important given the presentations we're talking about today. So to supplement what Danielle mentioned about geothermal energy, it is a process where basically it uses the heat, the underground heat, using a drill similar to what we see on the right-hand side, with certain characteristics that makes it similar to oil and gas exploration, although these wells are different in several ways. In that first, we're not looking for oil or gas, but instead it's about finding a source of heat with the proper heat conditions to be used, and which means that these wells have much higher temperatures. We're talking about wells that may be as deep as 2 and 3 kilometers with temperatures upwards of 200 to 250 degrees Celsius. These wells have different pressure characteristics, and they drill through rock that are higher in as far as mechanical strength. So you have to keep all these things in mind, because as far as exploration, this may be similar to oil exploration, but there are certain characteristics that are different. So why do I mention this? Because geothermal energy could be understood from two different standpoints, very similar to what happens with oil and gas, where first there's an exploration phase where drilling is done to see if a well can be properly used to generate electricity. And then there's a second stage where it is now the production stage, where the system, the heat exchanger, and the other devices are installed. And through the heat exchanger, the mechanical energy moves the turbine and thus generates electricity. So very specific to the Colombian context, research on the use of geothermal energy began approximately in 1968 in the volcano region of Nevado del Ruiz. Here, Italian researchers made these first steps in mapping the land, mapping information, diagnostics, and that study made it so that over time, since 1970 till today, many other studies have been done to expand the knowledge on geothermal energy in Colombia. For 2005, what was known at the time as INGEOMINES, which is currently the Colombian Geological Service, they created a map that we see here showing the geothermal gradients in Colombia. Understanding that a gradient is the change, it's a delta in the change in temperature as we drill deeper. So what we see in these areas is that these are interesting. There are certain regions that are more interesting, such as the region of Boyacá, and also in the department of Meta, and the area around the coffee region in Caldas, Risaralda, and Quindío.
The most recent studies today with this process indicate that should we be able to take the full advantage of the geothermal potential in Colombia, we could have an installed capacity of 1,170 megawatts. So it means that with current numbers and power generation in Colombia would allow to supply for 6.6% of the supply of the installed capacity. So should we be able to take the full advantage of geothermal energy, we could have 7% of all available energy in Colombia. And this installed capacity belongs to what Iritambo has, which is a project that is progressively entering into operation beyond the social and environmental connotations, and that is estimated to have a capacity of 2,400 megas, and it is currently in 1,200. So in conclusion, we could provide for all this energy. So this is a map generated by the Colombian Geological Service in 2020 that identifies in these polygons the areas with the highest geothermal potential, related specifically to the organic formations that go through the Colombian landscape in the central mountain range. Specifically, there's an area called the San Diego area in the north, the Paisa area, which is the one we find here in Boyacá province, with an interesting delta. Huila, that is also in the southern side, Cerro Bravo and Cerro Machín, that is the area that we will analyze. And in the Nariño province, we have the Chiles, Las Animas and Chiles in the boundary with Ecuador. They shelter lower sized polygons, the ones in black, that are called geothermal subzones, according to this analysis. And within these subzones, we will emphasize the Cerro Bravo and Cerro Machín, one called Nereidas Poterolono. So, generally speaking, the regulations in geothermal energy in Colombia it has started with the National Environmental System related laws in Colombia, all the way to those laws that regulated the energy sector in Colombia. And everything gains strength with the alternative energy sources that Andrés mentioned. This took place in 2014. And for the first time, geothermal energy was explicitly mentioned. But this is a very, it was about a description of geothermal energy without developing this concept. Traditionally speaking, alternative energies in Colombia beyond hydraulic energy that have been regulated the most are solar energy and wind energy. Work has been started to be conducted in ocean energy, like Andrés mentioned, and geothermal energy marked a starting point as of 2021 with Act 2099 that set out some requirements of how to explore and produce geothermal energy in Colombia in terms of the permits required before the Colombian government, and to conduct the research. And this was in charge of the Ministry of Mines and Energy. Also, the permits to conduct these activities with environmental feasibility, this was granted by the Ministry of the Environment, specifically the Authority of Environmental Licenses that would provide the permit, and so forth and so on. So there have been some regulatory standards that have been setting the specific conditions as to how the request is submitted before the Ministry of Mines and how is this permit requested to the ANLA, and the rest of studies required, so on and so forth. So I will mention some of the impacts by geothermal energy, emphasizing three components or three aspects that I analyzed in my project, which are hydrology, hydrogeology, and social components. So in terms of exploration, not the production, but the exploration, like it was mentioned at the beginning, it was something that may create significant thermal changes or alterations. So if they are not managed correctly, they can generate the mobilization of toxic substances in the underground areas, and heavy metals such as arsenic and other metals that can contaminate underground waters. And this could entail problems from the use of these sources are used for domestic purposes. In terms of surface water, there is an interesting consumption of energy in some studies conducted. It could be up to 2,000 liters per minute, a great consumption of water, and socially speaking. It has been found that even if these are alternative energy or projects, and they contribute to the climate change, these projects are focused on or similar to extractive industries, as it happens with oil and gas. So these projects entail social conflicts or resistance in certain populations, and the trend is that there's a benefit created with the extraction of energy, such as the creation of power, but there are some environmental liability. So the question emerges of who's going to be responsible for this. This happened in Kenya with the Masai community and a geothermal project that was developed there. And for the case of the limit with Ecuador and Colombia, or this country, there was a project called Tufino Chile's Cerro Negro, a binational product that had the resistance of the Gran Cubal reservation because they were not engaged in the process. So the exploration of hydrocarbons has entailed many social problems, and thermal exploration, geothermal energy exploration is in trend. So it is important to take this experience into account to avoid these social related problems, and to frame everything under the just or fair transition. In my thesis, as I had mentioned, there's an area called the Nereidas Botero Londoño area within the province of Caldas, Risaralda, and Tolima. This is one of the areas with the greatest number of geothermal studies conducted by the Central Hidroeléctrica of Caldas, which is a company managed by EPM, the electric generation company in the Caldas province. And with the studies, in this area of Nereidas, the Botero Londoño conducted a project called Valle Nereidas, or geothermal project and volcanic project. And for the purpose of this talk, we will refer to it as Nereidas or Valle Nereidas. So it is an area of 130 square kilometers, and to take advantage of a geothermal energy source of 1,500 to 2,500 meters in depth. This development in Nereidas obtained the environmental permit to be developed here in Colombia. It is called as an environmental license in Colombia in 1994. That permit back then was awarded by the Ministry of the Environment through Resolution 0211 of August 2 of 1994. And this permit is still valid at present, but it is being amended before the environmental authority called Corpo Caldas. Why is this license why is it modified? Was it being modified? Because with the permit in 1994, it was possible to conduct an exploratory drilling in 1997. We can see an image of the area where this activity took place. It's an area 10 kilometers away from the Santa Isabel volcano, and we can see what was done. It was 1,500 meters in depth, and they found a geothermal gradient above 200 degrees centigrade, which was not enough to take advantage of geothermal energy. And due to economic reasons, these efforts were not continued. So they just dismantled the project. They decommissioned the project, and the well was there, or the drilling site was left there, or the refrigeration. So what happened after this? In 2010, the decision was made of resuming this study in the context of diversifying alternative energy sources. And they said they did not want to make the same mistake and they made back then. They wanted to have more thorough studies to have more successful wells. So these all came to the need of not drilling just a well, but 5 different wells. In order to conduct geothermal exploration to determine whether this could be taken advantage of. So they are requesting, for this purpose, a modification of the environmental license to pass from 1 well to 5 different ones in the area that we can see in this image. This is called the N3 well, known as Nereidas 3, which is abandoned, and they want to carry out more drilling efforts in Nereida 3, RC2 and RC1. They are close to a river called Rio Claro. So in addition to drilling a holy well, they want to improve the roads, they want to better waste management facilities, and so on. So in a satellite image from Google Earth, we can see the location of the wells. We have the Nereidas 3, Nereidas 2, the ones that we had seen before in the first image. And there is a challenge because there's an approximate distance of 10 kilometers from the Santa Isabel mountain and a longer one to the Nevado del Ruiz. Why is this so? Oh, because they are related to the certain conditions in the subsoil that could lead to this finding this energy. We have the Ruiz and Cerro Bravo volcanoes. And well, this is if we should we be able to find this geothermal energy in these 5 wells, we would go from exploration, this initial stage that we were talking about, to the production, which is putting together a 65 megawatt plant in capacity to take advantage of this geothermal research and deliver or supply energy to the interconnected system. So in summary, suggesting this geothermal energy as electricity to the Colombian grid to address both industrial and domestic needs. So what is the tech losing or looking for? So in addition to providing energy, to be able to support the activity of supplementary activities in the area of influence. In what sense? That heat in the subsoil could have additional uses beyond electric generation. These uses could be pasteurization of dairy products in order to, for milk, for example. And this is considered because in the area of influence in the project, there is cattle raising, and that is related to milk production. And many of these growers or farmers have this need of pasteurizing milk. So this would be an additional benefit to the society, which in addition to producing electric energy, this geothermal energy could be used to pasteurize milk and also to provide geothermal heating uses. It also allows for heating systems, domestic heating services or systems. And we are talking about a very cold area in a cold climate, 2,600 above the sea level. So it's a very cold area. And we could also have some systems with this heating. What we are looking for in the framework of this energy transition is to say not only electricity would be generated, but this condition could also contribute to supporting the inhabitants of the area for better economic conditions and greater participations in their activities. Just like that I mentioned in the presentation, geothermal energy is a procedure that is quite costly, that requires detail and thorough research. And due to its characteristics, it's not as very simple for communities to understand what can happen. It's in contrast to a solar panel that could just be placed on the roof, right? So these are aquaponic systems with geothermal heating. And to end with, in line with what was mentioned at the beginning of my thesis, what we did was we analyzed environmental impacts, positive and negative impact. The CHEC was in charge of this. We used a methodology from the National University that includes complementary information or supplementary information to see to what extent this positive and negative impacts would change in water and underground water and in social arenas. So what we could see is that negative aspects had a greater significance, meaning that these impacts are more relevant and require a greater management, as we can see in the lower graphs, in the absence of irrelevant impacts. And we can see that the significance of negative impacts, meaning this tag, if we want to call it this way, the national government and the legislation would have to address this, and there would be an increase in 27% and in positive impacts, an increase of 31%. We can see in blue and yellow are the negative aspects, and the blue ones are the positive aspects, both in political, infrastructure, demographic, cultural, economic, archaeological, hydrology, and related aspects. So why am I saying that impacts become more critical in hydrology? This is because the project is located in a zone in which water has critical characteristics because it is close to one of the an urban area in Colombia with the greatest amount of wastewater produced in Manizales, Chinchina, Agua Maria, and the surrounding area. So this condition of affecting the quality of water is a precondition that already exists in the zone, and it has been considered in the project. And in hydrogeological, we can see that impacts become more critical because of the change in temperature, which is important. Because in the area, well, the water can be used for domestic purposes, but, I mean, even if it's not used for domestic purposes, there are some impacts that need to be considered such the project be conducted. We need to bear this in mind. So this is my presentation. I'm sorry for having such a long, covering such a long presentation in such a short time. Thank you, Pablo. This dialogue has been very insightful. It has included many different areas, a very broad approach. So we appreciate the fact that you try to cover it all because you have shared a lot. There is a lot to discuss. So from your work, we conclude this message. Research should be conducted with a local territorial approach, regardless of the fact that technologies are global, but for transitions towards renewable energies or clean energies globally. We need to conduct methodologies with local adaptations and not only export and models, we need to tailor them. So this is crystal clear about your presentation. From your presentation, this is what we take away. I would like to hand it over to Danielle in order to answer one of the questions that is being asked in the chat box, Danielle. I'm not sure how briefly you can answer this question. So thank you very much. Nicolas Hernandez says, thank you very much for your presentation. I'd like to ask if you have participated in any geothermal projects in Africa, and if you could share some specific details about the depth of the drilling and the amount of energy obtained, among others. Something similar to the study conducted by Pedro Pablo in order to have a better landscape of the situation in Cameroon and Colombia.
Okay, thank you so much for the question, Nicola. And what I can say is that they have not yet implemented in Cameroon, but what is already well implemented in Africa is in Kenya. And Kenya, for the report given by the Kenya electricity generating company, they usually give the capacity and also the total cost. So like they have many projects, and different projects having different capacity of power generation. So they have Okarial 6, 7, 5, and they're having different capacity of electricity generated and the different costs. If I can have a figure, I can give a figure. For instance, for Okarial 7 is about 80 megawatt, and the total cost was about 234 million of dollars. Yes. So now the indication concerning the I can put my camera on. The indication concerning the drilling and have not been given. So I read documentation and report from Kenya, and also I also read from the International Energy Agency. So most of the time they're giving the power, the capacity, and the cost of implementation. Yes. Is it okay?
Yes, thank you so much, Mari, for your presentation and your information. It was very amazing and interesting.
Thank you so much.
And thank you, Nataly. And thank you, Mary. Like I mentioned, this has been quite an ambitious dialogue, and our time is limited. So as to having a broader conversation between the four panel members, but we have noticed how these technologies and energy sources that we have called rare but relevant energies, that's how we named them from TRAJECTS, specifically in the case of hydrogen and geothermal energy generation. Research has shown that there could be a greater engagement specifically in the industrial sector. Energy in terms of favoring local consumption and prioritizing domestic use and needs. Well, it's a little bit more difficult with these energies requiring more complex technologies. In the case of some of the ocean energies, of course, we should place our attention to those territories that are closer to the ocean. Of course, it could be possible to have to foster distribution and use of energy for domestic and industrial needs. However, in today's dialogue, we talked a lot about the possibility of selling these energies and to benefit industrial processes, as well as fostering and generating more new employment, or more employment, which is one of the basic premises. But this also brings the question of what do we need so much energy for? So what should be the focus, the scope of this energy transition related research effort? So it is about supplying the needs, the local needs, or should it be generating a greater energy market, which also entails generating more energy needs, energy related needs in order to sustain the market and cells around energy? So that is a question that we are not able to answer, or we couldn't answer today, but it's something that we continuously ask ourselves when working in this area. What for? And how do we want to continue to produce energy? I would like to ask each one of you, given the fact that we have reached, we all agree that we need a mixed energy matrix, not one single type of energy could supply for all the demands, or it could be just the magic solution, like a magic bullet. It's a joint effort. So I would like to ask you, how would be that ideal blend, ideal mix of the energy matrix in order to favor actions against climate change? I know this is a complicated question, but I think this could be a good close for a good closing for the dialogue and to conclude our conversations. Andrés, over to you. Okay, so from the area I work with, I think the most important thing for this energy related efforts and aiming at addressing climate change, I think that part of the fair or just transitions is looking at a local scale. We cannot intend to solve development or sustainable development problems in territories without recognizing what are the resources we have at a local level. So if we are talking about geothermal energy, as my peers have mentioned, we should determine where are the greatest potentials or where are the greatest points of potential locally and plan actions accordingly. In marine efforts, it makes no sense to solve the energy problem in San Andres, to solve it to bring fossil fuels or because of the transportation and emissions and everything entailed. So it wouldn't make any sense also. Of course, there's a solar and wind energy potential there, of course. But for example, a turbine of energy for hydrokinetics that is conceived for a river wouldn't make any sense to place it in the island. Just to give any example, to place this in an area in an island where we don't have the mouth of a river or tidal energy, the ranges are about 30 centimeters, so it wouldn't make any sense to place it in the Colombian Caribbean Ocean, but it makes sense to consider tidal energy. So the first thing is to map what our colleagues are explaining for each country in the case of Africa as well. We need to tailor everything based on the potentials in every individual place, and we can start understanding things from local knowledge. We can generate local capabilities, local monitoring efforts, because it is the only way to tackle climate change. These macro global solutions must, of course, we need to have this type of conversations about them. But I think the first step is to recognize the local resources, local knowledge, and of course, having global based dialogues. Thank you, Andrés. Imane, would you like to add something? Would you
Yeah,
like to answer?
yeah. Thank you so much for this question. I think it's a very relevant question, and I also agree with Andrés that it's important to look at resources locally because there is the problem also of energy security and energy geopolitics. And once energy is like when we are dependent on other countries to procure our energy, it's kind of problematic. So it's important to have a mix of energy resources and to make sure to have or try to have the maximum of them domestically to mitigate this risk of energy security, as we have seen that sometimes energy is weaponized and is also used as a like for geopolitical to achieve some geopolitical objectives. So that's my contribution on the question. So thank you.
Thank you, Imane. Danielle, would you like to continue?
Thank you, Nataly, for the question. I think that our first goal is to be able to use the resources that are available. But we can also consider geothermal, the coupling hybrid geothermal and solar, as solar is really abundant, especially at the northern part of our country. But the fact that it's intermittent is not giving us full access of that particular source. So coupling geothermal and solar can be very good. But the problem now is the difficulty of implementation of geothermal in this region, Central and West Africa. It could be a very good solution to couple them, to have continuity of supply, but the limitation of difficulty of implementation of geothermal energy. Thank you.
Pedro? Thank you, Nataly. To your question, I would like to mention three things beyond geothermal specifically. The first is, if we want the energy transition to be just would mean that it has to have a broader scope and a broader participation as far as decision making, so that everyone could have a solar panel in their house, and so that everyone can also participate in decision making. In the geothermal projects themselves, the people living in the area should be heard as far as their concerns and needs, and to truly have a voice in the process. Not like with other hydroelectric projects in Colombia that, beyond the energy need, you know, it's no secret that there have been many issues, social and environmental issues, with regard to communities being displaced and other situations and implications that should be considered when incorporating new technologies. That, to me, is something that definitely has to be done if we want the transition to be truly just. The second thing that you mentioned very well is that there also must be a cultural change when it comes to energy. If we have a certain dynamic a certain consumption dynamic similar to what we've had in recent years, or to put it more clearly, we might have a 100% solar, 100% thermal grid. We would still have issues because there's still a demand for space and for water and for other resources that these energies require that are not clean per se. They all have their environmental implications, but there are certain implications. So that cultural aspect is important, as well as the use that we give to energy. Otherwise, we would be overexploiting natural resources. Now, locally, for Colombia, the climate crisis also means that every territory has to look at their own situations and see how they are contributing to the climate crisis, especially when it comes to extracting fossil fuels and other sources of energy. And in Colombia, the major issue is deforestation beyond any energy. We have to look at the triggers to deforestation and what leads to deforestation, and that must be addressed and mitigated as one of the main points so that Colombia can also contribute to mitigating the climate crisis. That would be it. Thank you. Very interesting what you're saying there about the fact that all technologies do have a certain impact to a lesser or greater degree. We've talked about this on other occasions. When we, for example, had the dialogue on nuclear energy, the nuclear waste and the critical minerals and other things that come from implementing nuclear plants. Well, there's no time to go through everything, but we should also keep those aspects in mind. And how, for example, infrastructure to create new kinds of energy or different kinds of energy means that there might be drilling in certain areas, sacrificing certain areas, and managing waste that cannot be recirculated or reintegrated properly into the cycles. Even if no greenhouse gases are being created from the energy we're producing, but it's really all about the secondary processes that would also have an impact. And that's something that we should also look at when deciding locally on what energy should be prioritized and what projects should be prioritized too. After having heard from all of you over these 4 dialogues, I can say that definitely not every country should back all kinds of energies. Just like Andrés mentioned. And also Danielle said this too. Knowing about the energy conditions, the solar and the heat conditions in each area is important when overcoming the shortfalls that each kind of energy has. But it's not that we should all look at doing everything that's available because, well, in the end, we might not be favoring the democratization of access to energy, access to water, and natural resources for biodiversity. So, we cannot just do anything to create energy no matter what, but instead have to really consider the context. I don't know if you might agree with what I'm saying, but I just believe that this could also be one major conclusion from these dialogues, saying that not everyone has to do everything, but everyone has to look at their own potential. And the governments should then prioritize or create a hierarchy as far as research and renewable energy sources, and maybe even rule some out, because not all industries have to have all kinds of energies at the same time. Okay, so I'll give you one last moment if you'd like to maybe tell our audience something else about clean energy and the just transition. Nataly, I would just add to something you said, which I think is very valid, in that the transition isn't just about migrating to certain energy technologies or diversifying capacity as a whole, but instead it's important just to be aware about how we use energy, who makes the decisions, and what roles should be assumed or changed to democratize energy, like you're saying, because otherwise what may happen, not certainly, but what may happen is that we will continue to follow the markets like we have been, with the difference that the energy wouldn't be oil and gas anymore, but instead would be alternative generation sources. The greenhouse gas factor is, of course, important, but it's important to look beyond that and keep the things in mind so that the focus is, let's say, broader. Andrés, did you have something? No, I would just thank you, Nataly, and all of our colleagues as well for having given us a very cross-cutting dialogue from your own context and your own standpoints around the just transition and climate effects. And it shows us how we are all connected, no matter how many seas and mountains we have between us, and how important it is to make decisions. I am totally aligned with what Pedro said, and with all the things you mentioned too. It's like the revolution of the small things. That's why I mentioned that definitely public policy has to be affected and governments have to be involved. But if you don't begin with that grain of sand, you cannot make the greater change. We definitely need that small action first and take action. Very important. Thank you. And thanks to all of you. I would like to especially thank Dr. Danielle, who, although is not part of the TRAJECTS network, she collaborated in this dialogue and allowed us to see a country with whom we have not had many relationships, because in our conversations, we always have South Africa mostly present. So it was really great to see other African countries that we don't know about, like Cameroon.
Thank you so much, Nataly. A pleasure is also mine to be part of this dialogue today. So I want to say that concerning energy transition, one important part is also the environment of the person. So renewable energy has the selection of our source of energy has also an impact on the environment and health. So like in our country, sometimes when there are some outages, we are using some fossil fuel, or we are using some fuel to power some generator, and that one bring a lot of pollution. So turning to green energy will be benefit for even for our health. So, but as Andreas said, we really have to consider what is available in our location and our country. So I would like to take the opportunity to thank also all the other participants and people that presented today. Thank you so much.
Thanks to you too. And yes, I totally agree in that the path forward is towards renewable energy. We definitely have to remove our dependency on fossil fuels, but that means significant challenges because we've been doing things this way for a very long time. But there are many alternatives to benefit health for the planet and for ourselves, human health and community health, and even non-human communities. So thank you very much. Imane, did you want to say one final comment?
Yeah. Thank you very much for the invitation today. I have also learned much about geothermal. I was so curious to know about the similarities and the differences with the oil and gas industry, and also to know interesting and relatively new to me ocean energy and how it can be very innovative. So it was very beneficial session to myself as well. And I think it's thanks to these kinds of dialogues that we can really have a bottom-up change and a concrete step towards just energy transition because the concept can be quite different from a country to country, as we have seen today, and from a context to context, and there is a lot to be done, especially in research, to unveil like these differences and to really see how a just transition will look like. So thank you, Nataly, and to the TRAJECT team and to all the presenters and the listeners.
Thank you, Imane, also for taking this Friday afternoon, well, I know it's 6 p.m. right now in Germany, to speak with us. And also for sharing. One of the best ways of doing research in green hydrogen and how in the whole range of hydrogen colors, we should definitely look at these kinds of hydrogens and not the others. I mean, that would be, I think, a very important decision to make when using these kinds of technologies and energy sources. So thanks to the four of you for participating, to everyone who joined us also. And especially to those of you who joined us in the 4 sessions. Hopefully this was valuable to you too, and hopefully you were able to expand your knowledge on renewable energy and the just energy transition. We hope you can join us next year in our dialogues on the just transition under TRAJECTS. Goodbye, and thank you very much also to interpreting and to our support team, Vanessa Munoz, Aranza Banda, and well, to all of you. Bye-bye. Thank you.